It's alright. Sean, you're welcome. Sumaya, you are welcome.
Hello, everybody. I hope all is well.
How has been the task for you?
A little bit easy. I just work with my partner, but still some checkers are red. We got like 88.
Okay.
And we having an issue when we give no parameter to the push. It's a default.
The push.
Yes. About checker 6 when we give no parameter to push function.
Okay, we'll look at it.
Okay, I will go on my PC because now I'm using just my smartphone.
Okay, please, yes, go on your PC, please.
Okay.
Alright, so quickly, maybe before we look at stacks and others, let's just have a quick overview of the Brainfuck task, okay? So I'm going to share my screen so you can see a whiteboard.
What I understand from the project is that they want someone to create a mini interpreter.
A mini what?
A mini interpreter for multi-language, like read each line and execute it.
Yes, that's for
the same logic as the simple shell. So this project is a little bit easy, you can say.
Yes, it's true. Okay, Mr. B.
Yes.
So, can you see my screen?
Yeah, I can see your screen.
Okay. So, basically, what the Brainfuck does is the task about the language. It's actually a language on its own, but it's not like your regular programming language. It was actually just developed so that you can practice your coding, or so that you can practice programming, let me put it like that. So you just rack your head around it, and it was made to be confusing. Do you understand? It's made to be a bit confusing so that your brain would have a lot to think about before
Understanding it.
yes. So you're supposed to have a lot to think about, really. I think someone tried to join. I can't see the request. Okay, so let me just continue. Alright, so basically what it does is, number one, there is a memory block, right, that is allocated, and each block is 1 byte. Each block is 1 byte, so that means it can take from 0 to 255 digits, 255 integers. So, and then I think it allocates up to, let me check the number of cells. So it uses a one-dimensional array of at least 30,000 byte cells. Of at least 30,000. Yes, so I remember someone's. I read somewhere 2 raised to the power of 16. So each of those cells are initialized to 0. So each of them are initialized to 0. So all the way, right? So you now have symbols. So there are different symbols. So it uses this greater than, less than, plus, minus, open square brackets, close square brackets, and full stop and comma. Let me try to get this properly. So you understand? So these are all you need. Do you understand? So when you start the program, this is array index of 0, right? So that's where it starts from. So 1, 2, 3, but your program will start from the array index of 0. So you use these greater than and less than signs to traverse the array. So that means if the first thing you put here, once you put this, now you know it starts from 0. So that means once you have this, that means you have shifted to position 1. Do you understand? You are now at index of 1. So whatever you are going to do will affect this index of 1. Now, the next here, the less than sign would shift backwards. Do you understand? This less than shifts backwards. So it goes this way. For the less than, it shifts backwards. So if you were in 1, you come to 0. And if you are in 0, you go to 30,000 and something, whichever, I don't know, whatever limit it will be on your system.
Okay.
So that's just basically what you need to understand about it, about this greater than. So greater than moves forward, the less than moves backwards. Now the plus and minus, you know, inside here everything is initialized to 0. Everything is initialized to 0. So if you have this plus, so if you have this plus, right, so it's the same thing as saying wherever you are, wherever index you are. For example, if you are at index 0, plus plus, so you increment it by 1 every time you write a plus, you increment it by 1. So the second plus, that means it becomes 2. Do you understand? So like that. So if you shift now and write plus, so that means you are not at index 1. So plus 1 now becomes 1, 2. Do you understand? So that's how you fill the arrays with numbers by the number of pluses you put, and then you move left and right to locate where you want to add the pluses. Do you understand? Hello, are you with me, Mr. Obi?
To move along the array, then use the plus sign to increase the value.
Yes.
So that will work.
Yes, okay. So the same way, the minus sign, wherever you are, you use the minus sign to decrement. Do you understand? but you must note that you cannot decrement beyond 0. If you try to do that, you are going to enter into error. Yes. Now, where it now gets interesting is the two remaining symbols. Okay, no, we still have like 4. So if you want to enter a loop, that's where this comes in. So these are for looping, right? So if you have a greater than, it must have a matching. I said greater than. If you have an open bracket, it must have a matching closed bracket. Do you understand? And what that does is that if the index, the present index where you are, if the present index where you are is 0, if the present index where you are, if it is 0, then the program is going to jump to the index after. Let's say maybe this is whatever index this is. Let's say this is I. Let's call this I. So it's going to jump to the index. That's I'm saying it's going to jump. Sorry, it's going to jump to the end of, not the index. I mean, it's going to jump to the end of your bracket. Do you understand? Hello? Hello, please. I need your feedback. Are you there?
Yeah, I'm here and I'm speaking loud. I don't know if you can hear me.
Okay, I can hear you now. I can hear you now. I said, do you understand?
Yes, but you said then the coily brackets, and I'm like, how, where are you the one that's going to put the where the closing bracket is?
Yes, you are the one that is going to put where the closing bracket is. It's part of the code you are writing. So
Okay.
right now, if you're at index 0 and the value of 0 is 0, do you understand? Everything you write inside this code, if you like, put plus plus, forward, plus plus.
Okay.
Do you understand?
Okay. It will still be
Backward,
from the index 0.
minus. So if you're at 0 here, if you're at index 0, if your I is 0 and the value inside that index is 0, what the code would do, or what the interpreter would do, is it will jump to the end of this. So maybe if you now continue writing your code, so to just read this. Do you understand?
So
But
whatever it will read inside there, it will read it for only that index 0.
no, it's not going to read it at all if it is 0, if the value is 0.
Okay.
But if it has a value other than 0, it's going to come to this point. Do you understand? It will read everything like this, then go back to the beginning, read everything, go back to the beginning, read everything. So what it means is that you have to find a way to create a loop. For example, if this is 1 and then you just write this code and you don't come back, you see here, let me try to make this clearer. Let me try to do this now. So let's say we are going to write a program now, right? So the index starts from 0 and everything is initialized to 0. So if I'm just at index 1, right, and I do this, I have a bracket and I do plus plus, oh sorry, I'm at index 0, this plus 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 this. Do you understand? All of this, instead of the interpreter to read this whole thing and interpret it, it will not. It will just jump to whatever I put afterwards. So this is where it will start. Why? Because this present index is 0. Do you understand? That's the value stored in it is 0. But if I have 1, stored inside, do you understand, which is non-zero, if it's just 1, right? So that means it's now going to look at what is here. So plus plus, at this moment we are putting plus plus, we have not shifted our index, we've not shifted our, yes, we've not moved our position. So what this does is, okay, something I didn't explain. Let me try to explain. I think I left that explanation out at the beginning. So what it does is that there are pointers. There are 2 pointers. There is the pointer that points to the array. Do you understand? That points to the index of the array, which is what this greater than and less than tries to shift. So when you see greater than, it shifts the pointer to the next point of the array. When you see less than, it shifts it backwards. That's what that pointer does. Then inside that array, right, these ones, the plus and minus, they point to the data stored inside the array and manipulate it. So they either increase it or reduce it. Do you understand? So as at this point now, I've not yet shifted, right? So my index is still at position 0, which has the value of 1. So in here now, we'll shift this to 2. This will shift this to 3, right? Then we encounter our first greater than, which now changes our index. Our index now, here was the index for I was 0 before, so now I becomes 2. So sorry, I becomes 1. So the index is now 1 because of this. So this one now shifts the value of I, which is 0 initially, right? So it now shifts it 1 plus plus plus. So this shifts it to 3. Do you understand? So at the end of the day, I now go forward again. Do you understand? I move forward with this again and have the index of 0. Now I encounter this closing bracket. The closing bracket will now check the index. Do you understand? It will come back here. It will check the index that called the loop in the first place. It will check the index that called the loop in the first place, which is I. Which is 0, I mean, index 0. And that index 0 contains is 3 presently. So then it will come back and then it will continue to execute all of this. Do you understand? It will continue to execute all of this. So it then means that this loop will run infinitely. So that means if you want to have a loop, a good loop, a working loop that will not be infinite, right? So let's go back, let's reset to 0. So right now I equals to 0, right? We're at index 0, and index 0 starts with 0. So if I want to do a working loop, right? So at this index let me put the value here so that I can have more space. So at this index I can put plus, right? Maybe I want to loop how many times? Maybe I want my loop to run 3 times. So I do plus. I've not yet changed. So that means this that was 0 before, right? Now becomes 3. Right? But we're at index 0. So inside my loop, maybe I want to maybe inside my loop I want to add here. Let's just do something. Somebody's trying to join. Who's trying to join? Okay, so inside my loop now, I want to maybe I want to multiply 3 by 3. Do you understand? Maybe I want to do 3 by 3. So in the next index that is 0, I increase by, oh, sorry, I've not yet moved forward. I need to move forward first. So we have to shift to the new index. So in there, I go to next, right? I shift by 3.
Let's put this greater than sign inside the loop.
Yes, the greater than sign is changing the index. You can move, of course, inside your loop, you can traverse the array inside your loop with this. Do you understand? So this will now be index 2 here. No, I'm sorry, index 1. So
One.
I will now be 1. So we now have I as 1, right? So I've increased it by 3, right? Then for me to go back so that this loop will not run infinitely, right? I'll call the less than, right? So the less than changes I to 0. So because of that, now I becomes 0. So I just want you to remember that this one now is index 1. So index 1 now has 3. Index 1 equals to 3. Let's put it like that. So after this, I must decrease this number. It's just the way we do in C, for example. Maybe you want a while loop. Maybe you say while I is greater than 0. While I is greater than 0. Then at the end of your, maybe I equals to 3. While I is greater than 0, I minus minus. Do you understand? So here, I will now write minus. So the program will now encounter the closing bracket. So at this closing bracket, it will now check. You know here that I put I minus. This puts I back at 0, abi? So the index is 0. What is in 0 is right now is 3. So with this minus now, I will decrement 3 by 1. It becomes 2. Right? So this closing bracket goes back to the beginning. Do you understand? And checks whether that index is 0. 2 is not 0, so it begins to run again. So this moves forward. I becomes 1. So I again becomes 1. So it adds 3 to it. 1, 2, 3, abi. So 4, 5, 6. So this becomes 6. So this is 6 now. Then it goes, we see the less than, right? So the less than changes index back to 0, right? Then you encounter the minus. Minus decreases the value, which is 2. It decreases it to 1. So here we now have 1. So we encounter our closing bracket. Closing bracket goes back to the beginning, right? Where this first bracket starts, and this first bracket now is at index 0, and the value at index 0 is now 1, right? So it's not yet 0. So our loop runs again. So it moves the index greater than to the next one. So this becomes 1. So the value at that position at 1 is 6, abi? So we encounter another plus plus plus, right? That's 3. So this becomes 9. then you come here, you see a less than. The less than sign means go back to the beginning, right? Go back one space, index becomes 0, right? So we are back at 0. And then 0, the value at 0 is what? Is 1. So 1 minus puts it now at 0. So now we see our closing bracket. The closing bracket jumps back to the beginning of the corresponding opening bracket, right? So the value now is 0. This bracket checks the value. If the value is 0, it jumps to the code after the closing bracket, which is this greater than sign. Now this greater than sign moves to 9. Moves to 1. Do you understand? Let me remove that so that we don't confuse ourselves with this. I didn't erase this. So, but let me keep this greater than this thing. So it moves to, there is a greater than sign. So it moves back our index to 1. So let me change the present index now to 1. Okay. So now, do you understand? I just used this to explain the loop. So that means with this loop, initially we had 3, right? So this loop, what this loop did was to multiply 3 by 3. Do you understand?
Yeah.
This loop multiplied 3 by 3.
3 by 3. Yeah.
So that's how you can do a multiplication.
Okay.
In fact, when I wrote my own multiplication function when we wrote our own, this wasn't how we did it. But this is one of the good things about explaining whatever you learn. When you explain, you learn more. This wasn't how we wrote our multiplication function. It was more complex the first time we were writing it. But now this is much better.
Thanks a lot. It's really a lot. Okay.
So now we still have 2 things, right? The full stop and the comma. So that still, those are 2 operators are still left, right? The full stop and comma. So what the full stop does is that it prints the ASCII value. It prints the ASCII value of whatever is there. So if you put full stop now, you will not print 9. It will not be 9 that will come out, but the ASCII value. So if you have to check your ASCII table,
See the value of what came out.
you see, yes, you see what 9 is. So you interpret what 9 is. So of course 9 will be an 9 is not a readable character. Do you understand? 9 is not a readable character. So it then means that what would happen would be that for you to have 9 which is readable, remember the character 0 starts from is 48. Character 0 is 48. So what you just do is you just add 48. You just add 48 to this position. So you can add this present index I. So before you click you put your full stop, which prints. So you can add 48 pluses, or you can use a loop to add 48 to it, whichever way. But you must just increment this. So you must do 9 plus 48. So you add 48 to it with pluses. Do you understand? So by the time you now have that, you can now add your full stop. So when you put your full stop, it will print the character 9 out. Do you understand?
Yes, I do.
Yes.
I
So the next thing is the last one is the comma. So the comma is what you use to take in input, right? So when you put a comma, you collect an input, and you can only take in a single input at once. Do you understand? You can only enter a single digit. Do you understand? So if you put one comma, and for example you put ER, it is the ASCII value of E and R that will be stored. Oh no, sorry, it is the ASCII value of R. If you put ER, it is the ASCII value of R that will be stored. If I'm correct, I'm not sure I'm getting that right, but maybe I don't know if it's the first one it will read or the second one that it will read.
But it is only one value.
It is only one value that it's going to read, but I'm not sure whether the first or the second. So, but when you need to take, for example, maybe you want to take in two inputs. Maybe at index 0 you want to take in an input, so you first write your comma, then you move to the next index, right? So this is now index 1. You can now write another comma. Do you understand? You write another comma. So what this does would be that if you write A and B, do you understand? If you input A and B, A would be in index 0, B will be in index 1. Do you understand? Remember, it is the ASCII value that will be stored. So for example, if you want to do mathematics, you want to do multiplication, and you enter 2 and 4, it will be 2 plus 48. 2 will be 50. 4 would be 52. So you want to do that, you must decrement those values by 48 to get the actual integer that you have. Do your multiplication. Do you understand? Do your multiplication, and then okay, now this is just for this code here does simple multiplication. That is why our ours was a bit more complex. This code only does simple multiplication. You will need to use loops to do your multiplications. So you can do your multiplication. Then when you now have your value stored somewhere, for you to print out that value, you add 48 to it. Do you understand? You add 48 to it so that you can get the ASCII value and the character, which is the digit. Do you understand? And then you now use full stop to print it out. Is that okay, sir? After you have computed and gotten your answer, then you will need to add 48 to that value before you print it. So you print with full stop, right? And then you take input with comma. Do you understand?
So you put the full stop immediately after where you want to print.
Yes.
Put the full stop
Yes.
after it.
Yes. Whichever index you are, if you're at any index and you put a full stop, it will print out the value at that index, the ASCII value of it. Do you understand? So that's why you do all your computation first of all. When you have finished your computation and you are sure that, for example, you want to print 9, you are sure that the value at that position now will be the ASCII value of character 9. That's when you now put your full stop. Do you understand? So just
Yes.
a summary of what we spoke about. The Brainfuck the Brainfuck language, what it does is it has an array. So that array is about 2 raised to power 16, right? Different That's different blocks, and each block is 1 byte. So that means each block can take from 0 to 256 or 255. I think it's 256. So from 0 to 256, and then there is a pointer. There is a pointer, so it has a pointer that traverses each part of the array. So when you click, when you use the greater than sign, you move to the next block. When you use the less than sign, you move to the previous block. When you use plus, you increment the value. Every block in the array is initialized to 0. So when you use the plus, you increment the value at the present position you are. When you use the minus, you reduce that value, you decrement by 1. So the opening and closing square brackets are for loops, and what it does is that when the program encounters the opening bracket, it checks the present index where it is. If that index is 0, it jumps to the end of the closing bracket and continues to read the code there. But if the index is greater than 0, then it will execute everything that you put in between the brackets. And then you can nest those brackets just the way you can nest loops in any programming language. You can also nest the brackets and put different brackets inside, but you must make sure that when you have open bracket, there must be a corresponding closing bracket somewhere. Do you understand? It has to be complete. If it is not complete, it will throw an error. And then you cannot decrement more than 0. If you try to decrement more than 0, you would enter into an error, out of range. Do you understand?
So
And then
you have
full
to
stop is to print,
print.
comma is to take in input. Any questions, please?
So you have to be specific of the how much you're incrementing and how much you're decrementing.
Yes, you have to be specific.
Alright. Thank you very much. At least this will give me a great base. I'll go and read up more, and I guess I'll get more understanding to it.
All right.
Thank you very much.
You're welcome. Any other questions, guys? All right then. So I think there is a clear button here.
Sorry, just confirming. This stuff is being recorded, right?
Yes, it is.
Okay. Thank you very much.
You're welcome, sir. Okay, I think there is a way for me to clear this board. I don't know why it's not clearing. Alright, but for now, let me stop sharing this. Okay, that's where it's appeared. Alright, so moving on. I think we're supposed to talk about the stacks and queues, right? Okay. So let me just open up my. Excuse me. Okay, guys. So this call will end in 15 minutes. We may need to reconnect after 15 minutes. All right. So this thing. So basically, what we need to understand the project. I'm just going to give us an overview of the project. Is not really. It's not really so difficult, especially if you've done the simple shell. It's not really so difficult. But the main concept. Let's just discuss the concepts of this project and what we need to understand. So number one is stacks. Let's talk about the stacks and queues. So I'm still going to share. I'm still going to share the whiteboard. Please, can you see this whiteboard, guys? Guys, please, can you see the whiteboard?
Signing in to open it.
Guys, are you with me? Okay. Asumaya, you're welcome. Alright, so let's continue, right? So, the concept of stacks, first of all, is just from the word. When you stack things up on each other, for example, you stack some books on each other. So, let's say you have book 1, and then you place another book on it. You place another book on it. You place another book on it. So what you have what you have here right now is a stack, right? So if you cannot have access, you cannot pull this book. If you try to pull this book, you would destroy everything. So the way to access things here is by removing from the top. So things come in from the top and then they are removed from the top. Though this was the first one that came, this is 1 2 3 4, right? This was the first one you put down. It is the last one you put down that goes out first. So that's why it has the what's it called, last in. LIFO is last in first out. Last in first out. So that's what a stack is. And then a queue, just imagine when you go to a bank. I don't know how banks work in maybe in your country where you are, but I know in Nigeria here, when you go to the bank, for example, you want to use the ATM, you have to enter into this long queue. And then let's say this is your ATM machine right here. You have the first person.
Moving them from CS training.
Sorry, Kolawole.
Yes, please.
So if I'm going to
They're saying some. So it's saying access denied for Google Jamboard.
Really? But can you see my screen?
I can see your screen, but it's not showing anything. It's just showing the ALX page.
Okay. Okay, let me just share the Jamboard. Let me share this window then. Let me just share this window. Okay, I'm sharing. Okay, can you see my screen now?
Yeah.
All right. So I explained stacks, right? Let me clear this. Let's just start again. Let's just backtrack. So I said stacks is like, for example, you want to arrange a book. You want to arrange books on your desk. So most of the times, I know that people arrange books on their desk by putting them on top of each other. So the first book you place down, you place the next book on top of it. You place the next book on top of it. Then the next one on top of it. Right? So if you want to get access to the last book, it means you would have to first take away the book on top, this thing up to the last one. So you have what we call, this is the bottom, and this is the top. So whenever you want to add something, maybe you want to add a new book, you have to place it on the top. And if you want to remove a book, you have to remove it from the top. Do you understand? So that is why it has the whole this thing of it's last in, LIFO. Then the other one is the queues. So for the queues, hello guys, can you follow? Are you following, please? Can you hear me?
Yeah, we can hear you.
Okay. So for the queues, I was saying, I don't know how it is in your country, but just imagine you want to go and use the ATM machine, right? In Nigeria, I don't know, it's rare, especially if you're in Lagos, to see an ATM machine that will not have anybody in front of it. But you have the first person, then you have the second person, you have the third person. So anybody that comes, right? Anybody that comes joins the back. Do you understand? Anybody that comes joins the back. So this is front. Let me just use the text. So this is the front, and then the back or the rear. So in this situation, whoever came first leaves first. Do you understand? Whoever came first leaves first. So that's how queues are. So queues follows the order of first in, FIFO. And there are different applications of these two. For example, your stacks. When you have to, if you look at assembly language, if you look at the Python interpreter, they all make use of stacks. So every operation that is supposed to be executed comes to the top of the stack. Once they get to the top of the stack, once they are done, they leave. If a particular operation calls another operation, that operation is added to the top of the stack. And then, the stacks will have to be executed from top to bottom. Do you understand? Stacks are executed from top to bottom, and they are added to the top. But for queues are executed from front to the rear, but new tasks are added to the rear. So an example of queues would be, I don't know if anybody does video editing and all of that, or sometimes you can even have downloaders. Maybe you have a downloader that can only download one file at once. So your downloader is basically going to have one file. After it has finished downloading that file, it goes to the next file. So that way it goes to the next file, So the first one, or you are editing videos, so the first video that you put into the queue, once that is done, before the next video will be rendered. After that is done, the one following it will be rendered. So those kind of applications use the queue's data structure for that. So usually that is what happens in your CPU. So your CPU most of the time uses the queue's data structure to operate. So first in, first out, that's what your CPU does. But when it comes to stacks, right, remember, assembly language and code, what they do is they load things into the memory. So when they load things into the memory, what happens is that there is a heap that is created, and then a stack is created, and then those instructions are loaded into the memory in stacks, and then they are put on top of each other, so that when you execute the last one that came in before that order will now go on till the end. So usually, for example, let's take C as the as C language now. The main would usually be at the bottom. Then, for example, your main calls another function. That function goes to the top. If that function calls another function, the function it calls goes to the top. So that way you have a stack. So until the last called function is executed, once that last called function is executed and then it returns, then the one that called it okay. So I think we can continue around, right? All right, so let's go on. So back here, I think the last thing I said was how CPUs use how CPUs use queues, how stacks are used in the memory, especially when calling functions and all of that. So the next thing will now be how do we implement stacks and how do we implement queues? We already understand two. By the way, the two of them are data structures, but they are data structures that can be implemented using two basic data structures that we already understand. So we understand linked lists, we understand arrays. So since we understand linked lists and arrays, one of the things is we cannot implement stacks using arrays, we can implement stacks using linked lists. But of course, you would understand that for a program like C, where this task is to implement a dynamic array in C is a bit difficult. It's a bit difficult in the sense that you would have to, for each time you want to add, maybe you have to reallocate, you extend the array, or you have to create, do a fresh malloc, copy over all the previous array to that one, free the previous array, and then you now add, maybe you add to the top or whichever way you want to add in arrays. So using C, that may be difficult, but of course using Python you can implement stacks or queues easily by adding to the front or adding to the back. But actually, in the real sense of it, Python will still do all of those things in the background for you. So you don't really have to bother about all of that in Python. But in this situation, we are using C. So if you are going to implement something like this in C, you the easiest way to implement stacks or queues is to have a limited stack, or you have a limited queue. So once all your, if I draw an array block, so once all the blocks are filled up, so that means if the index is already on this point, that means you have a stack overflow, or you have a queue overflow, whichever one you are using. So if it's full already, you have a queue overflow. And if you are going to implement linked list, sorry, if you are going to implement stacks in array, then um, I would say for it to be easier for you, depending on where you are doing it, I think it will be easier for you to put your top at the rear end of your array. Can you hear me, please?
Yeah, we can hear you. Your voice just got
Yeah,
clearer.
yeah, we
Okay,
can.
all right. So for you to implement it in array, basically you have to just maybe you set your pointer at the rear end, and then that's what you use as your top. But whichever way you can implement it using arrays. But to make things easier, I believe linked list is more dynamic, because the only thing is you just have to create your new node, right? Once you have your new node, you you can have a linked list already here. Let's say you have this, and better still, we just learned double linked list. We just learned double linked list. So this points to null, which is the beginning. The end points to null. So if you select this as the top and bottom, so let's say your top is the head. So of course, when you create a new node, you just have to add it to the head, and then this becomes your top. Do you understand? And then this becomes the head also. So it becomes the top. So, and then if you want to pop, you just have to remove this. You just have to remove it. Whatever is there, you just have to take it away. So that's basically what this is. So if you want to push, you add to the head of the linked list. If you want to pop, you delete the node at the head of the linked list. So that function is what we already have. We've already built that in the previous task. If you check the double linked list task, I'm sure we have the add to the head, we have the add to the bottom. So, and if it is a queue that you are implementing, so where would you add? You will add to the bottom. So a queue, you add here, you add to the bottom. If it's a queue, you add to the bottom. And then for pop in the queue, you pop the head. Do you understand? For pop, you delete at the head, because it's what? Last in, is first in, first out. So the head was added, the nodes at the head were added first, right? So for queue, what you are implementing is, when you want to implement pop in queue, you delete the head, and then when you want to implement push in queue, you delete the bottom, you add to the bottom, sorry. So you add to the bottom. So that's basically the logic you are trying to implement. So when it is linked list, let me clear this frame, and then let's just make some points. So linked list. So for stack, right? So what we've mentioned is pop. Okay, let's first do push, right? So push. So what push does is, for linked list, push adds to the beginning. or let me say adds to the top or the head of the list. Pop deletes node at head of the list. So, but for queues, what push will do would be adds new node to the bottom. So the bottom becomes the rear, right, of the list. And pop deletes node at head of list. So we can see that both of them will delete the node at the head of the list, right? But where it's different is where they push to. For stacks will push to the top, and queues would push to the bottom or will add to the bottom. So that's basically the difference whenever we are when we are implementing our own in the Monty interpreter. So the Monty interpreter has any questions on this before we just discuss on the Monty bytecode interpreter? Please, can we hear me?
We can hear.
All right. Any questions so far?
Not from my end.
Okay. So can we continue, please? Okay, guys. So switching back here, the Monty interpreter it's not much of it's not a difficult task, really, a difficult project to say. It's just that you may just need time to build the logic around it. That's just what the project does. It's just the time you need to build the logic around it. They've already given us the structures for us to use. For example, this is the structure of a stack. A stack here, hmm, an element of the stack in this Monty interpreter has an integer, and then it has the pointer to the previous and the pointer to the next. So what it means is that it's a double linked list. Right? We are going to work with double linked list in this task. And then they now give us the opcode. So this is what an instruction set looks like. So the instruction set, right, has its own, it's also a struct. It has the char, which is the opcode and then it has the function of the opcode. So that means this is going to be the prototype of every of the function we are going to use. So that means for you to be able to do this task, you must have a good understanding of function pointers. So it's that understanding of function pointers that you're going to use in this situation. So that means that you are going to have a function that whenever you read an input from the user or from the file, you read a line. Of course, not to speak about, but we should understand how to get line. We should understand how to break those lines into the line that we get. We should understand how we break them into different parts, how we tokenized when we did simple shell and got different arguments, right? So that's the same thing we're going to do here. We're going to get the whole line. We'll divide it into arguments. So when the first argument will be the opcode, which is a char. The first argument will be, so you should have a way to compare that first argument with all the chars that you are with all the opcodes that you have. So you will check. When you check, if it is available, if it is one of the functions you have built already, if it is available, then the next thing is that you are going to call the function with the argument that follows. So for example, in this push, a way you would implement push that I did was, after checking and seeing that, okay, there is push, right? I called push. But you see push here, they put 0, right? It's not that integer that was attached to push is not in the prototype of push. So that means that after you have called push, one of the things that you will check inside push is the second argument. Or another way you can do it is you can have a statement, a conditional statement that checks, okay, if the opcode is push, then I am expecting a second argument, the second argument should be an integer. So if that integer is available, then that means it's a valid argument. If it is not a valid argument, there is an error for you to print in standard error. Do you understand? And then if it is a valid argument, then when you are implementing your push, you will create a new node with that integer, and then you push it to the top of your stack. Do you understand? Do we understand, guys? Okay, okay, very good. All right, so that's it for push. So when you check, you find out that this argument is valid. Then you check the second argument, especially for push, which should have an argument that it takes itself. So if that is valid, you go ahead and do the operation. The other is I think there is PAL. PAL prints all the integers in the list. So just prints from top to bottom. We already have a function that prints list. You can go through your previous project. You will see the function that prints list. That is basically what your PAL is going to call. So what next here? Pins. Pins just prints the element at the top. So I don't think it's difficult. So Another thing is when you are checking all of this, is that you are checking to see if the list is empty. So for PAL, it says if the link is empty, don't print anything. But for Pint, if the list is empty, print the error. Stack is empty. So you must have a way to check whether your stack is empty or not. So going down for swap, you see there is this one here called swap. So all you just have to do is check if there are two, if the list is more than, if the length of the list is more than 2. That's what you should check. If the length of the list is more than is equal to 2, is 2 or more. Yes, if the length of the list is 2 or more, then you'll be able to, your swap should be able to, you can now perform the swap. Just get the integer value of the top element, store it in a temporary in a temporary variable. Then let the integer value of the second element be equal to um let the integer value of the top element, yes, now be equal to the second element. The integer value of the second element now be equal to the variable that you stored before. And that way you have performed the swap. So like I said, it's really not so difficult to do. So the same thing, add. So what add does is you take the integer in the first element, you take the integer in the second element, you perform the addition, and then you store it in the second element. After you have stored it in the second element, you delete the top element. So I think that's really the logic behind the project. The NOP does nothing. The subtraction, the same thing, it performs the operation. Division, the same thing, performs the operation, stores it in the one below. And if at all the top element is 0, because in division you are dividing the second element by the top element. So if at all the top element is 0, you cannot divide by 0, so you have to print the error. So really that's basically what is there. If you, even the advanced tasks are not so difficult. So a hint that I can give you that would also help you in doing this project so that things can be easy for you is you can create a data structure, right? Because this project allows us to have a single global variable. So the way you're going to do your global variable is you can create a data structure, and that data structure can contain maybe information about the top of your linked list, the bottom of your linked list, can contain information about anything, any information you want to pass around. You can put it there in that data structure, create it in data structure, then create a variable of that data structure in your main, right, as a global variable. And then you use extend. So you use extend of that variable in your monty.h, and then that way it is available all over your project. So that way it's easy for you to use free. You can free your list, you can free anything anywhere in your program, and then you will not have issues with malloc, you will not have issues with all of those things. Is that okay? Any questions, please? Okay, Sean is okay. Any questions, anybody? Okay, thank you, Obi. Sumaya, are you there?
Yeah,
Any questions?
I'm okay. Can you check on BF, the advanced, how to interpret them?
Okay, you're not here when we talked about BF.
No, I joined on while you were doing
Uh,
the stuff.
okay, it's we've actually gone far on BF. Okay, what will happen is I'm going to put this video, the video on YouTube.
Okay.
And I'm going to put the video on YouTube by this evening. So I'll put the link on the group
Okay.
so that you can go over it. It was the first thing we discussed. Is that okay?
Yeah. Yeah.
All right. So Chiemeka, are you there? Okay. All right, it's okay, guys. Mr. Timothy.
Yeah, I'm here.
All right, is it clear?
I'll wait for your video.
Okay, it's all right, no problem. It's okay, guys. I think we can call it a day, and then we will discuss later. If you have questions, you can always put it on the group, and then we'll try to answer those questions. All right, guys. So I'll send the video once it's ready.
Thank you, sir.
All right. See you guys later. Yes, Sean, that's correct.